The universe, a vast, seemingly infinite expanse of galaxies, stars, and cosmic wonders. Born from the explosive event we call the Big Bang, the universe has been expanding ever since. But as we gaze toward the future, one haunting question lingers. Will the universe itself come to an end? Just as it had a beginning, the cosmos may have an inevitable conclusion. Join us as we explore the most terrifying end-of-universe scenarios, each one more unsettling than the last. Before we delve into these dark possibilities, we need to understand how the universe has evolved. 13.8 billion years ago, the universe began with the Big Bang. It started as a hot, dense point that expanded and cooled over time, giving birth to galaxies, stars, and planets. But the same forces that created this universe may eventually lead to its demise. Scientists have proposed several theories, each explaining different potential endings to everything we know. Cosmic death scenarios. Let's begin with the most cold and quiet of them all, the Big Freeze. The Big Freeze, also known as the heat death, is one of the most widely accepted theories for the universe's end. Imagine a future where the universe continues to expand, and as it grows, the galaxies drift farther apart. Over trillions of years, the stars will burn out one by one, leaving behind only black holes, white dwarfs, and faint remnants of cosmic radiation. In this scenario, the universe would eventually run out of usable energy. There would be no more heat, no more light, just a dark, cold, lifeless expanse. The laws of thermodynamics tell us that energy will always spread out evenly over time, leading to a state of maximum entropy. When this point is reached, the universe would enter its final phase, cold, dead, and eternally still. This could be the ultimate fate of the cosmos, but it's not the only possibility. There are more violent ends on the horizon. Now let's turn our attention to a more catastrophic end, the Big Crunch. While the Big Freeze envisions the universe endlessly expanding into cold darkness, the Big Crunch is a scenario where the universe's expansion reverses. Instead of galaxies drifting apart, gravity pulls them back together. In this model, after expanding for billions of years, the universe would begin to contract. Galaxies, stars, and planets would be pulled back toward a central point. This process would accelerate until the entire universe collapses in on itself, reverting to a hot, dense state, similar to the conditions of the Big Bang. Some scientists speculate that this collapse could lead to a new Big Bang, a cyclical universe where creation and destruction repeat forever. But if the Big Crunch occurs, what would this mean for everything within it? Every galaxy, every star, every planet would be obliterated, crushed into a singularity from which no escape is possible. Now let's explore one of the most terrifying possibilities, the Big Rip. This scenario begins with the universe's current expansion, but here's where it takes a horrifying twist. What if this expansion isn't just constant, but accelerates to the point where everything, even the very fabric of space, is torn apart? Scientists believe that dark energy, the mysterious force responsible for pushing the universe apart, could eventually overpower all other forces. In this scenario, the expansion of the universe would increase exponentially, stretching and ripping apart galaxies, solar systems, and eventually atoms themselves. The Big Rip could begin billions of years from now, but once it starts, the end would come quickly. Within a matter of minutes, galaxies, stars, planets, and even subatomic particles would be torn apart. The universe would be reduced to nothing, a violent and instantaneous end to all of existence. But what if we survived long enough to see the death of black holes? In some scenarios, after all the stars burn out and galaxies have disappeared, only black holes remain. These cosmic monsters, known for swallowing everything in their path, might eventually disappear too. Black holes emit tiny amounts of radiation over time, known as Hawking radiation, and in theory this could eventually cause them to evaporate completely. But this process would take trillions upon trillions of years. In the end, after the last black hole has evaporated, the universe would be left in a state of absolute emptiness, a void where time itself no longer has meaning. While the Big Freeze, Big Crunch, and Big Rip are the most widely discussed theories, other more speculative scenarios exist. Some theories propose that our universe could collide with another universe in a multiverse, causing a cosmic apocalypse. Others suggest that quantum mechanics could trigger the creation of a new universe, or even that an unknown dimension could emerge and consume everything. The end of the universe is a terrifying yet awe-inspiring concept. Whether it's a cold and quiet death, a violent collapse, or the rapid tearing apart of everything, one thing is clear: the universe will not last forever. But as we ponder the vastness of the cosmos and its inevitable end, we are reminded of how precious our place in this universe truly is. The universe, vast, mysterious, and filled with unimaginable wonders. Born in the fiery explosion of the Big Bang, it has been expanding for nearly 14 billion years. But what happens next? As the universe continues to grow, will there be a final chapter, a silent end? Today we explore one of the most haunting end-of-universe scenarios, the Big Freeze, a cold, desolate, lifeless universe where everything fades into eternal darkness. To understand the Big Freeze, we need to go back to the beginning. About 13.8 billion years ago, the universe was born in a violent explosion known as the Big Bang. Since then, the universe has been expanding, with galaxies drifting farther and farther apart. This expansion was first discovered in the 1920s by astronomer Edwin Hubble, who observed that galaxies were moving away from us, a discovery that changed our understanding of the cosmos forever. But this expansion isn't slowing down. In fact, it's speeding up, driven by a mysterious force known as dark energy. As the universe stretches and grows, galaxies move away from each other at an ever-increasing rate. This has profound implications for the future of the universe, leading to one of the most chilling possibilities: the Big Freeze. The Big Freeze is a scenario in which the universe continues to expand indefinitely. In this distant future, billions of years from now, galaxies will have moved so far apart that they will no longer be visible to one another. But it gets worse, much worse. As the universe grows colder, the stars, those fiery beacons of light scattered across the cosmos, will burn out. Stars are the engines of the universe, but they don't last forever. Large stars will explode in supernovae, while smaller stars, like our sun, will slowly burn their fuel and fade into white dwarfs. Over trillions of years, even these remnants will cool down, becoming cold, dead black dwarfs, frozen embers of what they once were. One by one, the lights of the universe will go out. The sky will grow darker and darker as fewer stars shine. Eventually, no new stars will form, leaving the universe a dark, cold, and desolate place. As the universe expands, galaxies will drift farther and farther apart. In the distant future, a time far beyond human comprehension, galaxies will become isolated islands in the vast ocean of space. They will no longer interact with one another, and the night sky will be empty, void of the bright, distant galaxies we see today. The galaxies we see today, bound together by gravity, will be stretched apart by dark energy. Eventually, the gravitational pull between galaxies will be overcome by the relentless expansion, and each galaxy will be left alone, surrounded by an infinite void. In this frozen future, galaxies will no longer merge, collide, or interact. The universe will become a cold, dark place where stars no longer shine and galaxies float in isolation, unable to ever reach each other again. Even in this cold and lonely universe, black holes will continue to exist, consuming the remnants of stars and matter around them. These cosmic monsters will be the last active objects in the universe, but even they have a limited lifespan. Black holes slowly lose energy through a process known as Hawking radiation, proposed by physicist Stephen Hawking. Over a mind-boggling period of time, trillions of years, black holes will gradually evaporate, shrinking smaller and smaller until they disappear completely. Once the last black hole has evaporated, the universe will be left in a state of absolute darkness, cold, empty, and devoid of any activity. No stars, no galaxies, no black holes, just an endless void. At this point, the universe has reached its final state, maximum entropy. All matter has decayed, all energy has been used up, and the universe is in a state of equilibrium where no further events can occur. There is no heat, no light, no life. Time itself, as we understand it, becomes meaningless. Over time, Even the smallest particles will decay into radiation, leaving nothing but a thin, diffuse cloud of particles spread across an incomprehensibly vast and cold universe. This is the Big Freeze, a universe that has faded into eternal silence and darkness, where no new events can ever happen again. The Big Freezy represent one of the most chilling possibilities for the end of the universe, a future where time stretches on forever, but the universe grows cold, dark, and desolate. This silent death is a reminder of how fragile and temporary everything truly is. As we contemplate the cold and quiet end of the cosmos, we are left with a sense of awe, and perhaps a deeper appreciation for the fleeting beauty of the universe we live in today. For nearly 14 billion years, the universe has been expanding ever since the explosive event we call the Big Bang. Galaxies, stars, and planets formed, scattering across the vast cosmos. But could this grand expansion come to a halt and reverse? Could the universe, instead of expanding forever, begin to collapse? Today, we explore one of the most dramatic end-of-universe theories, the Big Crunch, a scenario where everything we know collapses into a fiery destruction of all existence. To understand the Big Crunch, we must first go back to the beginning. Around 13.8 billion years ago, the universe was born from the Big Bang, a singular event that caused the universe to expand from a single point of infinite density and heat. Since then, the universe has been stretching and expanding, with galaxies moving away from one another at ever-increasing speeds. This expansion is fueled by a mysterious force known as dark energy, which has accelerated the expansion of the universe over time. But what if one day this expansion stops? What if gravity, the force that holds galaxies, stars, and planets together, eventually wins and begins pulling everything back in? In the Big Crunch scenario, the expansion of the universe would one day slow down and eventually come to a stop. This could happen if dark energy weakens or reverses its influence, allowing gravity to regain control. If gravity becomes the dominant force, the expansion would halt and the universe would reach a turning point. No longer stretching outward, the universe would begin to contract. Galaxies would stop drifting apart and instead start falling back toward each other. Imagine the vast distances between galaxies shrinking as they start to pull closer and closer together. The once expanding universe now begins to collapse in on itself. Stars, galaxies, and even clusters of galaxies would all start moving inward, accelerating into what will become a violent cosmic collapse. As the universe contracts, galaxies would begin to merge in catastrophic collisions. The immense gravitational forces at play would lead to unimaginable destruction as entire galaxies collide and tear each other apart. Stars would be ripped from their orbits, planets thrown into chaos, and black holes would grow larger, devouring everything in their path. This process would happen across the entire universe, leading to a chaotic and fiery collapse. As more matter falls inward, gravitational forces would increase, and temperatures would soar to incomprehensible levels. The closer everything gets to the center of the universe, the more violent the destruction becomes. In this collapsing universe, black holes would play a significant role. As galaxies merge, their central supermassive black holes would also collide, creating even larger and more powerful black holes. These cosmic monsters would grow as they devour stars, planets, and even other black holes in a final feeding frenzy before the universe reaches its ultimate demise. Eventually, even black holes would be pulled toward the same fate. The entire universe would continue to collapse into an increasingly small space, with black holes at the center of this cosmic implosion. In the final moments of the Big Crunch, the universe would reach an incredibly dense and hot state. All galaxies, stars, planets, and even black holes would be crushed together in an ever smaller space. The temperature would rise to unimaginable levels, and the density of matter would approach infinity. At this point, the universe would be a super hot, super dense state, much like it was at the very beginning. The difference? This would be the end. The entire universe would be reduced to a single, infinitely dense point, a reverse Big Bang. All time, space, and matter would collapse into this final point, signaling the fiery destruction of the cosmos. But could the Big Crunch truly be the end? Some scientists have speculated that the universe might be cyclical, that after collapsing in on itself, a new Big Bang could occur, leading to the birth of a new universe. This idea suggests that the end of one universe could be the beginning of another. Perhaps in some distant future, a new cosmos could be born from the ashes of the old, starting the cycle of expansion and contraction once again. If this theory is true, the universe we know may not be the only one that has existed. Instead, we could be part of an endless cycle of creation, destruction, and rebirth. The Big Crunch is a terrifying and awe-inspiring vision of the universe's end. From galaxies merging in violent collisions to the entire cosmos collapsing into a single, fiery point, this scenario offers a dramatic and destructive vision of the universe's fate. Whether the Big Crunch truly leads to the end of all things or the beginning of a new universe remains one of the greatest mysteries of cosmology. The universe is full of visible wonders, stars, planets, and galaxies spread across the cosmos. But what if I told you that everything we can see, everything we know, only makes up a tiny fraction of the universe? In fact, visible matter accounts for just 5% of the universe. The remaining 95% is a mystery, dominated by a force we cannot see, touch, or directly detect: dark matter. Today, we'll explore the profound mystery of dark matter, the invisible force shaping the universe, and what its secrets might tell us about the end of the universe. So what exactly is dark matter? Dark matter makes up about 27% of the universe, while dark energy, another mysterious force, accounts for 68%. That leaves only 5% of the universe made up of the familiar things we can observe: stars, planets, gas clouds, and galaxies. But dark matter doesn't emit, reflect, or absorb light, which is why we cannot see it directly. In fact, dark matter doesn't interact with electromagnetic forces at all, making it invisible to telescopes and sensors. However, even though we cannot observe dark matter directly, we know it exists because of its gravitational effects. In the 1970s, astronomer Vera Rubin made a groundbreaking discovery when she noticed something strange about the way galaxies rotated. The stars in the outer regions of galaxies were moving much faster than they should have been. According to the laws of physics, galaxies should have been torn apart by these high speeds, yet they remained intact. The only explanation was the presence of some invisible mass, something holding these galaxies together. The gravitational pull of dark matter acts as a glue, holding galaxies together. Without it, the visible matter alone wouldn't be enough to explain why galaxies don't fly apart. But dark matter's influence goes beyond individual galaxies. It also plays a crucial role in the structure of the universe itself. It helps to form galaxy clusters and even shapes the large-scale structure of the cosmos. The universe is not randomly scattered with matter. Instead, it follows a web-like structure with galaxies forming along vast filaments of dark matter. This cosmic web holds everything together, and without it, the universe would look very different from what we see today. But what is dark matter really? The truth is, we don't know for sure. Despite decades of research, scientists have yet to discover what dark matter is made of. There are many theories, but none have been proven. One leading theory suggests that dark matter could be made up of weakly interacting massive particles, or WIMPs. These particles could be 100 times more massive than protons, yet they barely interact with regular matter, passing right through us and the Earth without a trace. Another possibility is that dark matter is made of axions, extremely light particles that also have almost no interaction with ordinary matter. Then there's the idea of sterile neutrinos, hypothetical particles that don't interact with any forces in the standard model of physics. To solve this mystery, scientists are searching for evidence in many different ways. From deep underground detectors to massive particle colliders, the hunt for dark matter continues. But despite their best efforts, dark matter has remained elusive, leaving us to wonder, what are we missing? Dark matter doesn't just shape the present universe. It also plays a crucial role in determining the fate of the cosmos. The balance between dark matter, dark energy, and ordinary matter will decide how the universe will evolve over billions or even trillions of years. If dark matter continues to hold galaxies and clusters together, it could prevent the universe from expanding forever and instead lead to a future collapse, the Big Crunch. In this scenario, gravity overpowers dark energy and the universe stops expanding, reverses, and begins to contract, eventually collapsing in on itself. On the other hand, if dark energy continues to dominate, the universe may face a different fate, the Big Freeze. Galaxies will drift farther apart, stars will burn out, and the universe will become a cold, dark, and desolate place. In this future, dark matter will remain as one of the last structures of the universe, long after stars have faded away. The deeper we explore the universe, the more we realize how much we don't understand. Dark matter is one of the greatest puzzles in modern science. It may shape galaxies, it may decide the fate of the universe, but we're still in the dark, literally and figuratively, about what it really is. If we could unlock the mystery of dark matter, it could change our understanding of physics, cosmology, and the universe itself. It's possible that dark matter holds the key to the universe's final chapter, and understanding it could bring us one step closer to answering some of the most profound questions of all. Dark matter may be invisible, but its effects are everywhere. It holds galaxies together, forms the structure of the universe, and may even determine how everything ends. As we peer into the night sky, we must remember that the vast majority of the universe lies beyond our sight, waiting to be discovered. Perhaps one day we will finally unravel the mystery of dark matter, and with it, unlock the secrets of the universe. The universe is filled with forces and phenomena that shape everything we know. Gravity pulls objects together, light allows us to see, and stars light up the cosmos. But what if there was a force more powerful than any of these, yet completely invisible and beyond our understanding? This force is known as dark energy, and it makes up a staggering 68% of the universe. Today we explore the most mysterious force in the cosmos, dark energy, and how it might hold the key to the ultimate fate of the universe. Dark energy is, in many ways, the most profound mystery in all of cosmology. We know that it makes up the majority of the universe, 68% to be precise. But beyond that, we know almost nothing about it. Unlike dark matter, which we know exists through its gravitational effects, dark energy has no direct interaction with matter. Instead, it acts as an unseen force driving the universe to expand at an accelerating rate. For centuries, scientists believed that the expansion of the universe, which began with the Big Bang, was slowing down due to the pull of gravity. But in the late 1990s, astronomers made a shocking discovery. The expansion wasn't slowing down, it was speeding up. Something was pushing the universe apart faster and faster. That something is dark energy. The discovery of dark energy came in 1998 when two independent teams of astronomers, while studying distant supernovae, made an astonishing observation. These exploding stars were dimmer than expected, which could only mean one thing. The universe was expanding at an accelerating rate. This finding sent shockwaves through the scientific community. It challenged everything we thought we knew about the universe's future. Up until this point, it was assumed that gravity would eventually slow down the expansion of the universe. But this new data suggested the opposite, that a mysterious, repulsive force, now called dark energy, was driving galaxies apart at an ever-increasing speed. This discovery led to the realization that the universe's ultimate fate could be far more dramatic than we had imagined. But what is dark energy, really? This is where things get even more puzzling. Scientists don't know what dark energy is, or where it comes from. There are many theories, but none have been proven. Some scientists believe that dark energy could be a property of space itself, a form of energy that fills the empty voids between galaxies. One possible explanation is that dark energy could be a form of vacuum energy, energy that is inherent in the fabric of space-time. Even in the emptiest parts of the universe, space is not truly empty. There is a certain amount of energy, and as the universe expands, more space is created, bringing more dark energy into existence. This would explain why the expansion of the universe is accelerating. Another theory proposes that dark energy could be a dynamic field called quintessence, which changes in strength over time. Unlike a constant vacuum energy, quintessence would evolve and shift, potentially explaining the universe's accelerating expansion. The truth is, we don't yet know which of these theories, if any, is correct. Dark energy remains one of the greatest unsolved mysteries in physics. While we don't fully understand what dark energy is, we do know that it will play a critical role in the fate of the universe. The amount of dark energy and how it behaves over time will determine whether the universe expands forever, ends in a violent tearing apart of space itself, or even collapses back in on itself. In one scenario, known as the Big Freeze, dark energy continues to drive the universe's expansion, causing galaxies to drift farther and farther apart. Over trillions of years, stars will burn out, and the universe will grow colder and darker. Eventually, no new stars will form, and all matter will be spread thinly across the cosmos. The universe will end in a cold, dark, and lifeless state, a frozen death. But dark energy could lead to an even more dramatic and terrifying end, the Big Rip. In this scenario, dark energy's influence grows stronger over time, eventually tearing galaxies, stars, planets, and even atoms apart. The universe would end in a violent, chaotic disintegration as the very fabric of space-time itself is torn to shreds. However, there is also a possibility, though less favored by current data, that dark energy could weaken over time. If that happens, the universe could stop expanding and begin contracting, leading to a big crunch, where the universe collapses in on itself, returning to a hot, dense state much like the Big Bang. This would mark the fiery destruction of the universe. Dark energy raises profound questions about the nature of the universe and its future. Why is the universe expanding faster and faster? What is the source of dark energy? Could it change over time, leading to new physics that we don't yet understand? And most importantly, what does dark energy mean for the ultimate fate of the cosmos? These questions remain unanswered. But with every new discovery, we come closer to understanding the mysterious force shaping the universe. The study of dark energy may one day reveal not just the universe's future, but also the fundamental nature of reality itself. Dark energy is the invisible hand that controls the destiny of the universe. It's the most powerful force we've ever encountered, yet we don't even know what it is. As scientists continue to explore this enigma, we may one day unlock the secrets of dark energy and gain a deeper understanding of our place in the cosmos. But until then, the mystery of dark energy reminds us of how much we still have to learn about the universe. The universe is vast and awe-inspiring, filled with wonders beyond our imagination. But hidden in the depths of space, there lies a force that may one day tear everything apart. Dark energy, an invisible force driving the accelerated expansion of the universe. It is the silent architect of the cosmos, pushing galaxies farther apart at an ever-increasing speed. But what if this force didn't just expand the universe? What if it ultimately rips the very fabric of reality apart? Welcome to the Big Rip, a cosmic horror where everything, atoms, planets, galaxies, could be torn apart in a catastrophic end to all things. To understand the Big Rip, we must first explore the force behind it: dark energy. Dark energy makes up 68% of the universe and is responsible for its accelerating expansion. But while we know that dark energy is pushing galaxies apart, we still don't fully understand what it is or how it works. Dark energy remains one of the greatest mysteries in cosmology. Dark energy acts as a repulsive force, counteracting the pull of gravity. The farther apart galaxies get, the stronger this mysterious force becomes. The expansion of the universe is not slowing down, it's speeding up. But what if dark energy continues to grow stronger, more powerful, and more destructive? Could it one day rip apart everything in the universe? In the Big Rip scenario, dark energy's repulsive force doesn't just cause galaxies to drift apart, it becomes stronger over time, eventually overwhelming every force in the universe. Imagine a future where dark energy grows so powerful that it can tear apart galaxies, stars, planets, and even atoms themselves. The Big Rip is the ultimate cosmic catastrophe, a scenario where the very fabric of space-time unravels. As dark energy grows stronger, the distances between galaxies will increase until they are completely isolated from one another. But the expansion won't stop there. In the final moments leading up to the Big Rip, the force of dark energy would begin to tear galaxies apart. Stars would be ripped from their orbits, flung into the vast emptiness of space. As the universe approaches the Big Rip, the destruction would become increasingly violent. In the final hours, solar systems would be torn apart. Planets like Earth would be ripped away from their stars, spiraling into the void. Stars themselves would be torn to pieces by the immense forces of dark energy. The entire structure of the cosmos would collapse. Imagine a world where gravity, the force that binds planets, stars, and galaxies together, can no longer resist the pull of dark energy. Every celestial body, from planets to stars, would be torn apart, atom by atom, in a cosmic slaughter. Even the black holes, those massive objects that devour everything in their path, would meet their end as dark energy rips them apart, leaving nothing behind but chaos and destruction. In the final seconds before the Big Rip, even the fundamental forces that hold atoms together would fail. Electrons would be ripped away from their nuclei, molecules would disintegrate, and all matter would be reduced to its most basic components. The universe would no longer contain galaxies, stars, or planets, just a formless, chaotic sea of particles spread across an ever-expanding void. Time itself may lose meaning in these final moments. With the universe expanding faster than the speed of light, no signals, no information, no life could survive or even communicate. The universe, once a place of beauty, complexity, and order, would dissolve into a formless chaos, stretching endlessly into oblivion. Could the Big Rip really happen? While the concept of the Big Rip is terrifying, it's important to remember that it is still a theory. Current data suggests that dark energy is causing the universe to expand at an accelerating rate. But whether this acceleration will continue indefinitely or lead to a catastrophic end is still unknown. Scientists are actively studying dark energy, gathering data from distant galaxies, supernovae, in the cosmic microwave background to better understand its nature. New observations from telescopes like Hubble and future missions may give us more clues about the true nature of dark energy. If dark energy continues to act as it does today, the universe could face a slow, peaceful end. But if it grows stronger, the Big Rip may be inevitable. The Big Rip is perhaps the most terrifying end-of-universe scenario, a cosmic horror where everything from galaxies to atoms is torn apart. It's a reminder of how little we truly understand about the forces that shape the universe. Whether or not the Big Rip will happen remains a mystery. But one thing is certain: dark energy will continue to push the universe into an uncertain and possibly catastrophic future. As we continue to explore the cosmos, we must confront the reality that the universe we call home may one day come to a violent and inevitable end. The universe is expanding, an undeniable fact we've known for decades. But what if this expansion didn't just continue? What if it accelerated to a point where the very fabric of space and time began to unravel? Imagine a future where dark energy, the mysterious force pushing the universe apart, becomes so powerful that it rips apart galaxies, stars, planets, and even atoms. This terrifying scenario is known as the Big Rip, the ultimate cosmic catastrophe where everything is torn apart, leaving nothing behind. Today, we explore the potential fate of our universe in the Big Rip. To understand the Big Rip, we first need to understand the force behind it: dark energy. Dark energy makes up a staggering 68% of the universe, yet it is one of the most mysterious forces we know of. It is responsible for the accelerated expansion of the universe, pushing galaxies apart at an ever-increasing rate. But where does it come from, and why is it growing stronger? Since its discovery in the late 1990s, scientists have been studying dark energy's effects on the universe's expansion. But as galaxies drift farther apart, the force of dark energy grows stronger. The question that haunts cosmologists is, what happens if dark energy continues to accelerate the universe's expansion without end? The Big Rip is a hypothetical scenario where dark energy doesn't just continue to expand the universe. It accelerates so rapidly that it begins to tear apart everything in its path. Picture a future where dark energy becomes more and more powerful, overwhelming the gravitational forces that hold galaxies together, the electromagnetic forces that bind atoms, and even the fundamental structure of space-time itself. At first, galaxies will drift farther and farther apart. This is already happening in our universe. But in the Big Rip scenario, this process will accelerate. Over time, even galaxies themselves will be torn apart. Stars will be ripped away from their galaxies, flung into the expanding void. In the distant future, billions of years from now, the forces of dark energy will become so powerful that entire galaxies will lose their structure. Stars, planets, and gas clouds will no longer be held together by gravity. Instead, they will be stretched and torn apart as they are hurled across the ever-expanding universe. As the universe approaches its final moments, even the stars themselves won't be spared. Dark energy will become so intense that it will overpower the nuclear forces holding stars together. The once glorious beacons of light in the universe will be shredded into pieces, leaving only fragments of their former selves scattered across an ever-expanding void. As we approach the end of the universe, the destruction intensifies. Dark energy continues to grow stronger, overwhelming not just galaxies and stars, but also entire solar systems. Planets will be ripped from their orbits, flung into the abyss, where they too will be torn apart. Moons, asteroids, and comets will all suffer the same fate, stretched and broken by the relentless force of dark energy. Imagine a world where no force, no structure, no object can resist the power of dark energy. Planets will crack, their surfaces ruptured, their cores stretched beyond their limits. In this future, even the strongest materials in the universe will be reduced to dust and scattered across the vast emptiness. In the final moments of the Big Rip, dark energy's influence will reach the very building blocks of matter, atoms themselves. The electromagnetic forces that bind electrons to their nuclei will be overwhelmed. Atoms will disintegrate, their particles stretched and pulled apart by the unstoppable expansion of space. This is the true horror of the Big Rip, not just the destruction of galaxies and stars, but the complete and total disintegration of everything, down to the smallest particle. Eventually, even the fundamental particles themselves, quarks, electrons, protons, will be torn apart. In the final moments, the very fabric of space-time will unravel, leaving nothing behind but an empty, cold void. The Big Rip is the ultimate cosmic catastrophe, a scenario where everything we know, from the largest galaxies to the smallest atoms, is torn apart by the relentless force of dark energy. It represents the end of everything: matter, energy, and even space and time itself. The universe, once full of stars, galaxies, and life, will be reduced to a cold, empty, and infinite void, expanding forever into nothingness. The universe, vast, ancient, and filled with wonders beyond our comprehension. For billions of years, galaxies have formed, stars have burned bright, and life has emerged in the depths of space. But no matter how eternal the cosmos may seem, it will not last forever. Whether it's a slow freeze, a fiery collapse, or a violent tearing apart, the end will come, and it may be more horrifying than we can imagine. Join us as we explore the terrifying possibilities of the universe's final fate. The universe began nearly 14 billion years ago in an event known as the Big Bang. From a single point of infinite density, the universe exploded into existence, rapidly expanding and cooling. Over time, galaxies formed, stars were born, and planets coalesced into the cosmic structures we see today. But even as the universe continues to expand, this process will one day reach its limit. Right now, galaxies are moving away from one another at an accelerating pace, driven by a mysterious force known as dark energy. This expansion is a key factor in determining the ultimate fate of the universe, whether it ends in a cold, quiet death or a fiery collapse. One of the most widely accepted scenarios for the end of the universe is known as the Big Freeze, or heat death. In this scenario, the universe continues to expand forever. As galaxies drift farther and farther apart, fewer stars will form, and the stars that do exist will burn out over time. Without new stars, the universe will slowly grow darker and colder. As the stars die, the universe will enter a long, dark age where no new light will be born. Planets will freeze and galaxies will become cold, empty shadows of their former selves. Eventually, all that will remain are black holes, dead stars, and the faint traces of radiation left from the universe's birth. In the final stages of the Big Freeze, even the black holes will evaporate, leaving behind a cold, silent void. The universe, once full of light and life, will be reduced to a dark, empty, and lifeless expanse, a chilling end where time and space stretch on forever, but nothing happens. The end of everything will be slow and silent. But the Big Freeze is not the only possible fate for the universe. In another scenario, the expansion of the universe could eventually stop in reverse. Known as the Big Crunch, this terrifying end would see the universe's expansion halt as gravity takes over, pulling galaxies, stars, and planets back toward a central point. Over time, the universe would collapse in on itself. As galaxies are pulled back together, collisions between stars and planets would become increasingly violent. Massive black holes formed from collapsing galaxies would grow larger, devouring everything in their path. The universe, once expanding outward, would now be collapsing inward in a fiery and chaotic reversal of the Big Bang. In the final moments of the Big Crunch, the universe would become a super hot, super dense point, just as it was at the moment of the Big Bang. But this time, instead of exploding into new life, the universe would collapse into nothing, ending in a fiery implosion that marks the destruction of all existence. While the Big Freeze and Big Crunch are based on gravity's influence over the universe, there is another, even more terrifying possibility: the Big Rip. In this scenario, dark energy doesn't just push galaxies apart. It becomes so powerful that it eventually tears everything apart, from the largest galaxies to the smallest atoms. At first, the effects of dark energy would only affect galaxies, pulling them farther apart from one another. But as the universe's expansion accelerates, dark energy would grow so powerful that even individual galaxies would be torn apart. Stars would be ripped from their orbits, and planets would be flung into the void. In the final moments of the Big Rip, even the fundamental forces that hold matter together would fail. Atoms themselves would be torn apart, the very fabric of space-time would unravel, and everything, galaxies, stars, planets, atoms, would be reduced to nothingness. The universe would end in a violent, chaotic tearing apart, leaving behind only a cold, dark void. Which of these terrifying scenarios will come true? The truth is, we don't yet know. Scientists continue to study the universe's expansion, trying to unlock the mysteries of dark energy, gravity, and the forces that shape the cosmos. Every new discovery brings us closer to understanding the universe's fate, but the final answer still eludes us. The universe is vast, beautiful, and terrifying. Whether it ends in a cold, silent death, a fiery collapse, or a violent tearing apart, one thing is certain: the end will come, and it may be more horrifying than we can possibly imagine. The universe has existed for billions of years, but it will not last forever. Everything we know, from the smallest atoms to the largest galaxies, will one day meet its end. The only question is how. Will the universe freeze into eternal darkness? Will it collapse in a fiery explosion? Or will it be torn apart in a violent cosmic rip? Whatever the answer, the end of the universe is a reminder of the fleeting nature of all things, even the cosmos itself. The universe is full of mysteries, some beautiful, others terrifying. Among the most feared and fascinating phenomena in the cosmos are black holes. These cosmic monsters are the remnants of stars that have collapsed under the weight of their own gravity, creating regions of space so dense that not even light can escape. Today, we will explore the terrifying power of black holes, their role in shaping the universe, and what they might mean for the ultimate fate of everything. Black holes are formed when massive stars, many times larger than our sun, reach the end of their life cycle. After burning through their nuclear fuel, the core of the star collapses under its own gravity. If the star is massive enough, the collapse is so intense that it creates a singularity, a point in space of infinite density. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape, not even light. This is what makes black holes so terrifying. Once something crosses the event horizon, it's lost forever. The event horizon is the point of no return. Anything that passes this boundary is doomed to be pulled into the singularity at the center, where the laws of physics break down. Time and space are distorted, and even light itself cannot escape the immense gravitational pull. Black holes are unlike anything else in the universe. Their gravitational pull is so powerful that they distort the very fabric of spacetime, bending light and stretching matter in a process known as spaghettification. As objects fall toward the event horizon, they are stretched and torn apart by the difference in gravitational force between the front and back of the object. Imagine a star being devoured by a black hole. As it approaches the event horizon, the intense gravity stretches it into a long, thin stream, tearing it apart atom by atom. This is spaghettification, one of the most terrifying aspects of a black hole's power. Once the star crosses the event horizon, it is lost to the black hole forever, destined to merge with the singularity. Black holes don't just consume stars, they feed on anything that gets too close, from gas clouds to entire solar systems. As material spirals toward the event horizon, it forms a glowing disk of superheated gas known as an accretion disk. This disk glows brightly as friction heats the material to millions of degrees, creating one of the most energetic phenomena in the universe. In some cases, black holes also produce powerful jets of energy that shoot out from their poles. These jets can extend for thousands of light years, sending streams of highly charged particles deep into space. It's a reminder that black holes are not only destructive forces, but also play a key role in shaping galaxies and influencing their surroundings. At the heart of nearly every galaxy lies a supermassive black hole. These black holes are millions, or even billions, of times the mass of our Sun. They are responsible for holding entire galaxies together, anchoring the orbits of stars and planets within their gravitational grip. Our own galaxy, the Milky Way, has a supermassive black hole at its center known as Sagittarius A-Mo, with a mass 4 million times that of the Sun. These supermassive black holes are so powerful that they shape the very structure of galaxies. Stars near the galactic core orbit at incredible speeds, pulled in by the immense gravity of the black hole. While they remain invisible to our eyes, their presence is revealed through the motion of nearby stars and the glow of their accretion disks. But black holes are not just cosmic monsters. They may also play a crucial role in the end of the universe. As stars burn out and galaxies fade, black holes will be among the last remaining active objects. Over billions of years, they will continue to consume whatever matter is left, growing larger and more powerful. In the distant future, black holes will begin to merge, creating ever larger singularities. Eventually, there will be nothing left for them to consume. The universe, once filled with light and life, will be reduced to a cold, dark void, populated only by black holes and faint traces of radiation. But even black holes will not last forever. In the final stages of the universe's life, black holes will begin to evaporate through a process known as Hawking radiation. Over trillions of years, they will slowly lose mass, radiating away tiny amounts of energy until, at last, they vanish completely. When the last black hole evaporates, the universe will be left in total darkness, an empty, silent void where nothing can ever happen again. Black holes, once the most terrifying forces in the cosmos, will fade into nothingness, leaving the universe in its final, desolate state. Black holes are among the most terrifying and mysterious objects in the universe. They have the power to consume everything that crosses their path, from stars to entire galaxies. And while they may one day be the last remnants of a dying universe, their ultimate fate is to fade into nothingness. In the end, even the most powerful forces in the universe cannot escape the march of time. Black holes are some of the most terrifying and mysterious objects in the universe, capable of devouring anything that comes too close. But what lies at the very heart of a black hole? Deep within the event horizon, where light, matter, and even space-time itself are pulled into oblivion, lies a singularity, an infinitely dense point where the known laws of physics cease to function. Today, we explore the singularity, one of the greatest mysteries of modern science, and ask, could the answers we seek about the end of the universe be found in the heart of a black hole? A singularity is a point in space where gravity becomes infinite, and matter is compressed into an infinitely small volume. It is thought to form when a massive star collapses under its own gravity at the end of its life. The force of the collapse is so great that it compresses the star's core into a singularity, a point of infinite density where the gravitational pull becomes so strong that nothing can escape, not even light. The singularity is hidden deep inside the black hole, surrounded by the event horizon. This boundary marks the point of no return. Once anything, whether it be matter, light, or even time, crosses the event horizon, it is pulled inexorably toward the singularity, never to return. As an object approaches the singularity, strange things begin to happen. The gravitational pull becomes so intense that the very fabric of space-time is warped beyond recognition. Time slows down, distances become meaningless, and the forces that govern the universe, such as gravity, electromagnetism, and the strong nuclear force, start to break down. The closer you get to the singularity, the more the laws of physics as we know them begin to fall apart. In the singularity itself, gravity becomes infinite and space-time curvature becomes infinitely steep. At this point, our current understanding of physics, particularly Einstein's theory of general relativity, can no longer explain what happens. It's as if the very rules that govern the universe collapse in on themselves. Despite decades of research, scientists still don't fully understand what happens at the singularity. The infinite density and the breakdown of physical laws make it impossible to directly observe or model what's really going on inside. General relativity predicts that space and time come to an abrupt end at the singularity, but this prediction doesn't match up with the other pillar of modern physics, quantum mechanics. Quantum mechanics governs the behavior of the smallest particles in the universe, and it suggests that the laws of nature shouldn't break down, even in extreme environments like the singularity. But so far, scientists haven't been able to reconcile these two theories. General relativity and quantum mechanics cannot both be correct at the singularity, and understanding what happens inside a black hole remains one of the greatest challenges in theoretical physics. But singularities don't just raise questions about black holes. They may also hold clues about the ultimate fate of the universe. In the distant future, long after all the stars have burned out and galaxies have faded, black holes will be the last remaining objects in the universe. As they continue to consume matter, they grow larger and more powerful, potentially merging to form even more massive singularities. Eventually, the universe could become dominated by black holes, each containing a singularity at its core. Could these singularities represent the final stage of the universe's evolution, where all matter is compressed into infinitely small points? If so, what happens next? Does the universe collapse into a singular state, or does something new emerge from the ashes of the old? To truly understand the singularity, scientists are searching for a unified theory of physics, something that can explain both the very large, like black holes and galaxies, and the very small, like atoms and quantum particles. This theory of everything would combine general relativity and quantum mechanics, finally solving the mystery of what happens inside a singularity and unlocking the secrets of the universe's most extreme environments. There are many theories that aim to explain the singularity, from string theory to loop quantum gravity, but so far none of these have provided a complete answer. The singularity remains an enigma, a place where our current understanding of the universe breaks down and the answers we seek slip just out of reach. The singularity lies at the very heart of black holes, an infinitely dense point where matter, energy, space, and time are compressed into a single point. It represents the ultimate breakdown of the known laws of physics, a place where our understanding of the universe falters. But while the singularity remains a mystery, it may also hold the key to the future of the cosmos. Will the universe itself one day collapse into a singularity, ending in a final point of infinite density? Or will it give rise to something new, something we cannot yet comprehend? With gravitational forces so strong that nothing, not even light, can escape, they represent the ultimate boundary between life, death, and the unknown. But what happens if you get too close to a black hole? Today we explore one of the most horrifying concepts in astrophysics, spaghettification. As you approach the black hole, your body would be stretched and compressed into long, thin strands in a process so violent, so extreme, that it defies comprehension. Join us as we take a journey into the terrifying realm of spaghettification. Spaghettification is the term used to describe what happens when something falls into a black hole. The intense gravitational forces near a black hole cause objects to be stretched vertically and compressed horizontally, turning them into long, thin shapes like strands of spaghetti. The closer you get to the event horizon, the stronger the gravitational pull becomes. But it's not the uniform pull that causes the stretching. It's the difference in gravitational force between the top and bottom of an object, known as the tidal force. For large objects like stars or planets, spaghettification happens over a long distance. But for something as small as a human, the process would be immediate and terrifying. The gravitational force acting on your feet would be far stronger than the force acting on your head, stretching your body into an impossibly long, thin strand before you even have time to process what's happening. To understand the horrors of spaghettification, we need to dive deeper into the physics. A black hole's gravitational pull increases dramatically the closer you get to its center. This means that if you were falling feet first into a black hole, the gravitational force on your feet would be much stronger than the force on your head. This difference in force would pull your body apart, stretching you vertically and compressing you horizontally in a process known as tidal stretching. The tidal forces grow exponentially stronger as you approach the singularity at the heart of the black hole. No matter how small the difference in gravitational force starts out, it quickly becomes overwhelming. For an object like a human, the stretching would be extreme and violent, with the body becoming thinner and longer until it's nothing but a strand of particles spiraling toward the singularity. But what would it feel like to experience spaghettification? As you fall toward the black hole, the world around you would begin to distort. Light from distant stars would be stretched into long arcs, and space-time itself would warp and bend. You might feel the immense tidal forces pulling at your body, but before you have time to react, the stretching would become overwhelming. Your body would be pulled longer and thinner, the force becoming so strong that it overcomes the bonds between your atoms. The process would be so extreme that not even the bonds holding your atoms together could resist it. Your body would be reduced to a stream of particles, stretched into an impossibly long line, spiraling toward the singularity at the center of the black hole. Time itself would appear to slow down as you cross the event horizon, but by then, it would already be too late. There is no escape. While spaghettification sounds horrifying for a single person, it's even more terrifying on a cosmic scale. Entire stars and planets can experience spaghettification when they venture too close to a black hole. The immense gravitational pull of the black hole stretches these massive objects, pulling them apart atom by atom in the same way it would stretch a human body. In some cases, this process can create stunning displays of energy. As the star is torn apart, the intense gravitational forces heat the gas and dust, creating glowing streams of matter that spiral into the black hole. These tidal disruption events, as they are called, are among the most powerful and energetic events in the universe, releasing immense amounts of radiation as the star is consumed. The most terrifying aspect of spaghettification is that there is no escape once you've crossed the event horizon. The event horizon is the boundary surrounding a black hole, the point at which the gravitational pull becomes so strong that not even light can escape. Once something crosses this boundary, it's doomed to be pulled toward the singularity at the black hole's center, where it will be stretched and compressed into nothingness. As you approach the event horizon, time slows down from the perspective of an outside observer. But for you, the experience would be terrifyingly quick. The moment you cross the event horizon, there is no return. You would be pulled into the singularity, and no information, no signal, not even light can escape from that point onward. Spaghettification is one of the most terrifying concepts in astrophysics, a reminder of the immense and destructive power of black holes. Whether it's a human body, a planet, or an entire star, nothing can resist the tidal forces that stretch and tear everything apart. Black holes are the ultimate devourers, consuming anything that crosses their path, stretching it into oblivion as it spirals toward the singularity. In the end, nothing escapes, not even light. The universe has existed for billions of years, filled with stars, galaxies, and the wonders of cosmic evolution. But like all things, it is not eternal. Whether through a slow, silent freeze, a fiery collapse, or the violent tearing apart in the Big Rip, the universe will one day face its end. It is a sobering reminder that even the vast cosmos, so full of life and energy, is finite. The end may come in a way we cannot yet fully predict, and the mysteries of what lies beyond still elude us. But as we explore the universe, we gain not only a deeper understanding of the cosmos, but also a clearer perspective on our place within it, brief and fragile in the grand timeline of existence. If you found this exploration of the end of the universe fascinating, be sure to like, subscribe, and leave your thoughts in the comments. How do you think the universe will meet its final fate? Thank you for joining us on this journey to the edge of time and space.